Okay, so welcome back. Our next speaker is Taco Conning. He's a Holland-born and Canada-raised with a Bachelor in Science in Geology in 1971 from the University of Alberta and a BA in Economics in 1981 from the University of Calgary. He has worked for 50 years in oil and gas exploration and development as a geologist, manager, and executive, including he was Vice President of Exploration for Texaco Canada Petroleum Incorporated. Approximately 20 years of his working life has been in Calgary, and he's also lived and worked for 30 years in Indonesia, Nigeria, and Angola. Since about the age of 10, he has an abiding interest in fossils and the fields of paleontology and geology. This has led him to being an active member of the Alberta Paleontological Society, leading annual field trips to see the KPG mass extinction boundary at Knudsen's farm near Huxley, Alberta. Also for APS, he leads a half-day Tyndallstone tour to view the 450 million-year-old Ordovician-age fossil-rich decorative limestones in inner city Calgary. So if you're a type of person that really is not really good for the field, this is a perfect opportunity to go downtown and see excellent fossils. Okay, so pass it on to Taco.
I really appreciate the opportunity to give this talk. Let's get going on this. So I'm sure a lot of you people have never heard of Driftwood Canyon Provincial Park, where they have these fossil beds. So that's the road going in. It's a good road. You can go in with just a normal car. You don't need an SUV. This is 10 kilometers north of Smithers, which is in northwest BC. And this is the sign saying, okay, the park. It's a small park. It only covers 140 acres. It was created in 1967. The landowner donated it. It also has a short wheelchair-accessible interpretive trail leading from the parking lot to the fossil beds. It's open year-round. But, of course, if there's really heavy snow, you wouldn't get in. We were there in October. This is the outcrop of the shale. So you can see these are people per scale, and you can see it's roughly about maybe 20 meters thick, and it's fairly fractured, natural fractures, and then all that rock falls down into that scree slope, and where you can collect it. This was in October, first week of October, we were there, and you can see all the scree over here. I'm hanging on to some scree. My wife took the picture, got to give her credit for that. I'm a geologist, I'm not a paleontologist. I first went to this fossil bed in 1968. So I was 18 years old, and at that time I was at a park, and I helped myself to some fossils. I was working in the sawmills in BC, and these are some of the fossils which I collected some 60 odd years ago. If you want to see them afterwards, you're welcome to see them. So I'm not really an expert on it, but I really did study all of the literature. Every piece of stuff that was published about the driftwood, I incorporated that into this PowerPoint. And if you want a copy of the PowerPoint, come see me. My phone number here and my email address. You're very welcome to have a copy of it. So this is Smithers, British Colombia, and it is just up north there. This is Prince George there, and it's sort of 3/4 of the way from Prince George to Kitimat and Prince Rupert. This is more detail here. This is in the highway, Burns Lake, and blah, blah, blah. There's Smithers over there. And then by the time you come over here, this is Kitimat. Okay, so the ocean comes through over here. So again, Smithers just up there to the left. And that's where, and it's located along the Bulkley River, and I'll get more into that. So this is a surface geology map. It's very complicated. Basically, it's a lot of volcanics and metamorphic rocks, and then you have pockets of sedimentary rocks, of Jurassic, Cretaceous, Tertiary age sedimentary rocks. And it's highly structured because of the Pacific plate colliding with North America, and that's why you have all this intense structuring. It's one of the richest fossil beds in the province of British Colombia, the Driftwood Shale. The depositional environment was a tropical swamp and lake, and is recognized as one of the world's most significant Eocene-age fossil beds. It's the premier location in BC for studying Eocene warm climate ecosystems. And it's also famous because it's the most northerly site in North America for Eocene insects. So if you're into bugs, especially Eocene bugs, this is a place for you. But I realize that not everyone in the room is going to go running up there to look for Eocene bugs. So the climatic conditions, the climate was very different at that time. It was substantially warmer, and there was no ice on the south and north pole. Most of the earth was blanketed in tropical forests. Temperatures were balmy, seas were warm all over the world. Why did this happen? So you had this naturally enhanced greenhouse effect. The CO2 levels were much higher. What caused it? From what I can see in the literature, nobody is still understanding why the Eocene was such a hot time. Perhaps there were some big volcanoes going off in some parts of the world, sort of trapping in the heat. I don't know, but it certainly was. So this is a map from Rob Blakely. North America by that time was fairly stable. Europe was still totally structured. You can see Europe there with all those delineations and different islands. And so, but again, on the south, there's no ice, okay? Just a little bit of ice in the north, no ice in the south because it was hot. So now we're going to start looking at some of the rocks here. And this is my hammer for scale. And that is a ash bed over here from the volcano. A volcano went off and spewed a whole bunch of ash into the atmosphere. Looking at that in more detail, here's the ash in white. That was age dated radiometrically, uranium, lead, isotopic age dating at 51.7 million years old. And so that really nails it down. And just above it, you can see kind of a bit of it, a shaly unit, kind of poker chip. And I think that's because when all that dust settles into the lake, you would have had argillaceous material also settling in the water and then forming that lake of that layer. But then once you get up in the round layers, that is lacustrine. And so those are bars, VAR bars, and they're about 1 millimeter thick, and they kind of show the lake going through kind of a temperate time and back, the annual change in temperature. It's a fascinating opportunity to understand the evolutionary process in that area in terms of the evolving geology and the evolving paleontology. And so you had the slow deposition of fine mud in the lake, and that trapped these organisms. Each layer represented 1 year in the life of the lake. And then but there's no oxygen in between. So when the layers kind of compacted, there's no oxygen in between those layers. And that had the effect that if there's organic stuff in between, it didn't decompose, okay? It didn't decompose and it's kind of stayed fossilized. And I'll be showing that to you. A few more things before I start showing the actual fossils. So you had flora. The flora, botanists have just found pine, alder, birch, cypress, elm, ferns, hemlock, oak, pines, ginkgo. But the most common is a kind of ancestral redwood type of tree. And the fauna included insects, water striders, aphids, marsupials, mosquitoes, gnats, ants, termites, weevils, beetles, and wasps. And I'll show some of those. And the fish included a kind of the ancestral salmon, suckerfish, trout, and bullfins. And they've also found a couple of fossilized bird fossils, which I will be showing you also. This, I'll just fly through this, but the geology of the area in Smithers, you got Jurassic volcanics, Upper Jurassic is sedimentary, eminence bearing towards Hazleton. Then you have Upper Cretaceous volcanics and sedimentary rocks, and then in the Tertiary, what we call the Paleocene, that also included the Driftwood Shale. And these sequences are all intruded by Jurassic and late Cretaceous plutons, okay? And so you had these intrusions made their way through. So it's a structurally complicated area, but that adds to the fascination of the area. So now we're getting into the site. So that's the trail going in. And see, it's a good trail. Signs saying fossils protected. You cannot take out any fossils. Okay, it's prohibited. And of course, you're wondering, what am I doing with these rocks? Well, I was only 18. The park had just gotten started. There's no signs up. So these are legitimate. Okay. Hopefully, I'll not go to jail for having those. So as you walk through there, you can see this on the left there. And these are some of the trees. It's almost like a rainforest there. You can see these trees are 30, 40 meters high. And then they have these dioramas kind of explaining the fossils that you see there. So this is just a bench, and people realize that they can't take out the fossils. So what they do is if they see something of interest, they just put it on a bench. That's an example and you can see it's very fissile. It's a very fissile shale. Now, the environment at that time, this was a image by somebody called Julius Cosentini. But this is the way he saw the Driftwood Canyon during the Eocene. And they have seen evidence of taper called heptadon. And then they also have a little hedgehog. It's only 5 centimeters long. A hedgehog, so it'd be like 2 inches, shown over here. There were mammals, but for various reasons I don't quite understand, that very few that were preserved. But you can see it was quite a kind of a warm, almost tropical type of environment. This is one of the fish that they have found, fossilized fish. They call it Eocene driftwoodensis, and it's one of the oldest specimens of fossils. So you did have salmon in the early Eocene. Okay, so this is the salmon. You can see it's very well preserved, the head and the rest of it. Here is another salmon. Again, this Eocene-age driftwoodensis. Here's the head over here, and you can see some of the fins and the thorax, very well preserved, and it gives you some idea of the environment of deposition. And again, you're in a lake, you're not in the sea. So they only found 2 birds, and this one they found in 1970. So it was a piece of shale, which when they split it apart, they found both sides of it. And again, you can see it's a very fissile shale, and here's all the feathers, and here's the legs. Of course, this is the mirror of that side there, but the head was gone. Okay, the head was gone, unfortunately. You can see the feathers were preserved, were not decomposed. So these are there's a museum called the Bulkley Valley Museum in Smithers, and this is from their collection. It's not all that clear, but you've got everything from little water spiders to ants and to also wasps. And I'll show you more detail, but like this would be a water strider up there with the long legs. That'd be a water strider. Now this goes to show how well some of this is preserved. I mean, you can see the water strider just up there, another one over there, and this wasp over here, and then this very delicate, beautiful leaf. Something I'm not a paleobotanist, so I can't tell you what it is. This, again, is a blow-up of one of the wasps. This wasp is 50 million years old. You can see the wing, you can see the little veins in the wing, okay? And then at the bottom part, you see some sort of a decorative assemblage. And of course, you have the spear near the head. I mean, if you had been living in the Eocene at this time, you would not want to run into a bunch of those things. And so the plants, again, the Metasequoia foliage over here, ginkgo. And so this would have been roughly about 30 centimeters, so fairly large leaf. And this is the scale over here. So this is an older Rusa. It was about 8 centimeters in length. And that is what I've got over here. And you can see, again, the veins in the leaves. This is a sequoia leaf. This for scale, you can see it's about 6 centimeters in length. This is a Pinus nidalis, 6 centimeters. These are pine branches. On the edge of these shales, you had some kind of weathering. So that's what gives this color over here. Those are, I think those are pine branches. And then this is a very delicate leaf, which I think is from an alder, and which over here. So, and it's about 7 centimeters in length. And a tree branch, okay, which I've got over here also. And so there's tree everywhere. This is a trunk of a tree fell over, and people just put all their fossils in there, something they thought of interest. I picked up off the ground. You can see a little leaf, So it's kind of a fascinating area, and particularly if you're interested, if you're kind of a paleobotanist, you'd have a great time here. The little one that just picked this up off from the ski slope. You can see the leaf there to the left and leaf over here. Why study the Eocene? It's also in relationship to today's global warming. Further paleontological research in Eocene areas like the Driftwood Canyon will help get an understanding of life at that time. Okay, high CO2, what impact did it have there? So, but if you look at it now we're going back to a greenhouse environment. Why? Because there's 8.3 billion people on Earth. There's 8.3. I'm one of them. You guys are one of that whole group of people, and we are burning through coal like crazy. We're going through 100 million barrels of oil per day, and then a huge amount of natural gas. For sure, we're getting into a whole new climate because of climate change. And so the studying of paleontology in places like Driftwood Canyon could help us to understand the possible responses of plant and animal communities due to that projected climate change. So to me, the study of the Eocene is not pure academic. It's very practical reason for continuing with that research. This is a map showing the early Eocene. They call it the Okanagan fossil beds, and Driftwood Canyon is right to the very north. Then you have also Eocene, the horsefly beds, the Maccabee. The Maccabee is quite famous in the world of paleontology, and Princeton, Auckland. And there's another famous site which is Republic, just across from Washington. And Georgina Hoffman was going to take us there for a field trip last summer.
And this summer too.
What? Oh, this summer. Okay.
As well.
Okay. So there's going to look at the EUC. That's assuming you want to go to the States. Okay. So this is the driftwood and how it fits in with its stratigraphic counterparts in North America and Europe. So the driftwood is 61.7 million years old. The caribou beds, we call the horsefly, is 50. Cache Creek, which is the Maccabee beds, is 52 million. And then going over into Alberta, you've got at the confluence of the Blind Man and the Red Deer Rivers near Macomb, and those have been dated as 60 million. Okay, so those are 10 million years older than the ones that the driftwood. The Bulkley is about 50 million. And then if you go to the Green River Shale in Wyoming, that's 53 to 48 million years old. And last year I also gave a presentation about the fossils in the Messel pit in central Germany, and those are 47 million years old. So that gives you kind of a feeling how these beds correlate with similar age beds in British Columbia and Alberta. Smithers area, it's a beautiful area, one of that Bulkley River Valley. This is a museum in Smithers. Smithers is a small town, but 3,000 population. And there's a really nice museum, and they also have a small collection of fossils from the driftwood. This is the Bulkley River Valley. This is the Smithers, just on the edge of Smithers. You've got other towns, Hazleton, Delphoi, Houston. It's a beautiful, peaceful area. The people are very welcoming. Maybe you should just start thinking of staying at home this summer in Canada. Instead of stressing yourself out going across the line. I'd just like to thank the people organizing this event. I love coming to this forum, and great turnout, interesting. So I just thank my wife because she's often pushed me to go on these trips that we call the road less traveled. in the years, I've had opportunities to look at all sorts of paleontological sites in West Africa, Central Germany, Cuba, Nova Scotia, North Dakota, Waterton, Banff National Park, Manitoba, and Lacombe, and the last one now has been Smithers. It's easy to not stick your neck out and stay home and relax and take it easy, but you get out to these fossil sites and sometimes they're not so easy to get to, but they're fascinating places and you learn a lot. So thanks to my wife for pushing me into these situations.
Okay, so we have time for one question. Oh, over here.
What group of species of bird, like what kind of species of bird fossil is it?
You know, if you buy the book, the abstract book for $10, it's in there. Okay.
Okay, that's fair. Okay.
I can't remember.
Yeah. Okay. Okay, that's good. We'll just hold it off there. Chuck will be around if you have more questions. Oh, and so we're giving him a year of membership, but he's already at 2030, I think so. So he's at 2031 now. Thank you very much. And Taco was elected to get a copy of the Guide to Common Vertebrate Fossils from the Cretaceous of Alberta. I kind of wish we had a shorter name for a book. But anyway, here we go. Well, thank you very much, Taco.